For showing up so many of you, and thanks to some, he just escaped. I know he's there for facilitating the organization of today. So let me present myself. My name is George Kohnen. I'm the head of data science at VP. I don't know if you know VP, but I'm going to explain it in a second. VP may be better known in Benelux as Vente Exclusive before, and Vente Privé in France. And I've been at the company for close to 6 years now, first as a data scientist, after my previous life as a physicist. And now since 1 year I'm in charge of the data science department. We're a bunch of 15 people all over Europe, well, mainly France, Spain and Belgium. And I'm also very happy to have here today with me Uri, who's going to be the main speaker of this, and Robin, who's, those guys are my two managers who really run the day-to-day business in our data science operation. So I'm going to quickly introduce VP to you, and also telling you what, apart from personalization, we do in data science at VP, and then let Uri tell you more about the main subject. Damn, this is low indeed. Okay. So VP is actually, I think, the biggest in terms of turnover and member base, the biggest flash sales e-commerce website in Europe. What are flash sales? Well, flash sales are just simply sales that last for a certain duration. The idea of it's not like Amazon with a constant offer. Let me try to. Does it work? Not sure. Display. Now it works. The first aim of VP was to actually sell stock from brands, stock from last year, excess stock that they didn't manage to sell, and just take the stock from them so they don't have it on their hands anymore, and sell them at discount prices to our members. It was a very attractive price, and giving visibility to the brands also at the same time. So just a few key figures. The total revenue, business revenue of the VP group in Europe was in 2020 close to 4 billion euros with 66 million members, 4.5 million unique visitors per day, active in 10 countries, but on 11 sites. We'll explain that because somehow we have already split Belgium in two, which will not be the case, of course, but we have a French-speaking website and a Dutch-speaking website in Belgium. We are quite 1,000 people in total. You just talked about gender equality. That's a very nice connection because there's around 50% of women in the managing structure. But unfortunately, we're not at 50% in tech at VP either. Of course, unfortunately, we're trying to do what we can there, but I think everybody has basically has the same trouble in the VP. So what is VeepeeTech? Well, it's very easy. It's tech of VP. It's the IT department of VP, if you want. We're responsible basically for keeping things running on our website, putting our offers on online, handling payment, handling logistics, handling samples, managing pictures of samples and descriptions of products and etc. So the whole logistical production and logistical chain that we operate, that we support VP's business with. Not going into any details here because it's not today's aim. It's really low. We're distributed over 6 countries, 11 cities, as far as Tel Aviv, as you see in Warsaw. 80 product teams from product teams that specialize in writing logistics software to navigate the teams that put sales online, etc. I know it works. I did it earlier. Okay. And we're about 800 full-time equivalents in VeepeeTech, including the data department, which is about 50 people. This includes also contractors and freelancers, etc. Yeah, a few logos about technology. We're going to go into details that, at least for data. What's important here to see is that that we're working on the Google Cloud Platform on the data side. Most of VP services are on-premise, but we're working on the Google Cloud Platform for data. And one of the VeepeeTech's aims and priorities is also the gender equality, where we're trying to support women to grow in the field, and not just inside the company, but also encouraging women to take careers in tech, which is where it all starts, basically. I mentioned it earlier. VP is a construction of One Privé in France, from Prévalia in the south, and of those two countries, they are not really at their correct location. This was Mexico and Brazil. Prévalia was present there as well, and Vente Exclusive in the Benelux. So we're actually out since 1 year, more or less. We're out of a several-year convergence phase of really converting those three platforms together in just one single platform, which was a very challenging endeavor. Quick words about data science at VP. What do we do? We have what we call more an operational efficiency track, where the idea is to where we put in more forecasting topics to help, for example, how our warehouses organize themselves, to help pricing decisions, etc. We'll do search optimization, image recognition techniques, etc. And we have, and that will be the main topic of tonight, personalization track, where the aim is to bring the right offer to the right member at the right time. So basically, when somebody opens the VP app, which drives at least 3/4 of our traffic, you should see in the first few banners that you see there something that is of interest to you. That's the aim of personalization. So I think that's now the right moment to hand the mic over to Uri. He's the PO and manager of the personalization team at VP, and he's going to explain to you all this in more detail. Thank you. Does it work? I liked it now.
Hey, you want to pay? But I will try to explain. We'll see. George has put the standard very high. So hello everyone. My name is Oriol Roqué. So here, so you can see the screen. So as George said, in VP we're providing personalization. So we're going to see how are we providing personalization. But I think first it's important to understand why are we providing it. What is the value that we are actually achieving by personalizing the member experience in VP. See if this works. Yeah. So this is some of the latest results that we observed from an A/B test. Here we're testing 4 different variations of personalization, so with some tweaks on the model itself. This is from November last year in France. And we're comparing versus what we call the merge, the manual ranking. This is on the homepage of VP. It means that the manual ranking, all customers will see exactly the same ranking. And it's some people from marketing that will do this ranking. And what we can provide is actually a ranking that's going to be unique for every customer, and that actually intends to achieve better conversion, better turnover, and so on. In this case, this is a site conversion rate, so mainly what we are not working anymore. Okay, well, just run here. Generally speaking, without going into too much details, we are providing 16 to 18% more buyers, so people that is visiting VP actually ends up purchasing something. And in terms of turnover, so load booking, we are achieving 15 to 17% more turnover. Of course, it depends on the different variations. That's why we are doing A/B tests and so on. So there's indeed a huge value, and this is at the end on site visitor, because site visitor is any unique visitor. If you visit today VP, you come to VP, you are considered a site visitor. So indeed, this multiplied by the number of daily visitors that George was explaining before, this actually can mean a lot of impact that we are actually achieving with personalization. So as we see, we are to achieve a very positive performance. So what is our goal? Our goal is to provide a personalized ranking. And the idea of this personalized ranking is, of course, it needs to benefit VP, but also needs to give visibility to the brands. So at the end, we are a B2B company, B2B2C. And by giving a certain visibility to the brands for the members that are interested in them, to the customers, we are actually helping both of them. So customers will be easily finding what they are actually looking for in VP, and the brands would generate more sales through and so on. So actually, this is actually helpful as well for them. A quick constraint in terms of technical constraint. This happens on the homepage. So whenever you connect to VP, the ranking of the sales needs to update real time. Like it cannot stay uploading there for 4 minutes. So in terms of response time, this is one of the main challenges, and it's actually what drives part of the technical decisions that were made back in the time. And we need to answer, the maximum answer needs to be in 100 milliseconds. We'll see that the product that we developed, data science product, is in average 35 milliseconds, so that's really relatively fast. And what happens as well is that at 7 a.m., as VP is mainly driven by Flash, at 7 a.m. most of the new offer appears, meaning that there's a lot of peak of traffic in that period, and we need to be able to provide this personalized ranking in there as well, and we can have peaks up to 200 requests per second as well. So the service needs to be available and so on and so forth. And there's some fallbacks in case we don't reach these strategies, but for me the main idea here is to keep in mind also the technical constraints. In terms of business scope, I'll go a little bit fast on this one. Our main benefit, the results that we were seeing before, comes actually from the homepage. So whenever a customer connects to VP, this is the landing page. Here we have all the offers and so on. We have different sections, different sales. And here it's the ranking of these sales that is actually the scope of personalization. And we are available in 8 countries. I think on the previous slides it was 7 countries, so I'm confused now. I think it was from 30 to 20, so this is up to date. And we have 11 sites, not one extra, because we have the Privalian VP in Spain and Italy, and the 2 sites in Belgium. Of course, this by ourselves, data science, we are providing the recommendation, but the recommendation itself is useless. So of course we are, in this case, collaborating with different other products teams that we have in VP. In this case, it is the navigation team. They are in charge of the front of the different home pages. We also provide another scope of personalization. In this case, is for the emails, the daily emails invite. So each time we can choose to receive certain communications every day with the sales that will open today. This, for instance, is in Privario, so it's in Spanish. So these sales here are actually as well personalized. And this is with another team in VeepeeTech. It's same, available in all countries, all sites. And there's also the push notifications. In this case, what changes is the brand name, the brand that appears in the order. This will be different for every customer. And this is available in France, but currently we are extending this as well to other countries. Okay, so I will stop with the boring stuff. Let's go to the topic. This is a deep ranker. Deep ranker is what we call the algorithm because it's a fancy name. So it's a it was chosen, I guess. So let's see exactly how are we handling this. So the problem that we want to solve, the data science problem or the business problem, is we have a customer, in this case, that connects to VP. I will focus mainly on homepage, so it's easier. So a customer connects to VP, it lands on the homepage of VP, and we would have a set of sales that are available at this time. I don't know, in this case, we can imagine a homepage of just 8 different sales. So how we can provide a ranking that will maximize the chances of this customer purchasing. There's 2 main hypotheses here that we do. First one is, of course, the sale that is going to be more likely to be purchased would be on top. So we are assuming that the more a customer needs to scroll, the less chances of purchasing. And second thing is that, of course, in order to maximize this chance, this ranking needs to be unique, needs to be personalized. And in order to achieve this, we use deep ranker, so it's this machine learning algorithm. A quick update, well, a quick not update, a quick check on classic approaches for this recommender system approach. Classic one would be content-based. So mainly if we have this customer that have purchased this kind of items here, what we could do is, this item looks similar as the one that this customer has already purchased, so let's recommend this item. The problem here is that we face with the cold start, meaning that when a new member appears or connects to VP, we don't have that much information of this member. We don't have information of what this customer would have purchased because it's new. And also we can end up in a low diversity on clustered recommendations. So this is not the way that we are actually providing the recommendations. Another one could be collaborative filtering. So in this case, we say, okay, these two customers have purchased the same set of products. So we can consider them as similar users. And if customer A has bought this product, we could potentially recommend it as well to customer B. In this case, we have also called the star situation, but on items in this case. An item has to be purchased at least once in order to be recommended. And we have the snowball effect. And this is important as well because the core business of VP is flash, meaning that each day we have new sales, new items. And also we have probably lack of context as well because some of the purchases and the offer that we have would depend on the time of the year as well, meaning that we'll not always have exactly the same offer, so it would be a little bit more challenging to provide this kind of recommendation. So what do we do? We don't have items, we are doing sales, we're just for exemplification purposes. We mainly compute affinity score. Meaning affinity score, it's we have one customer, we have one sale, we compute a value, this is a score, and the idea of this score is that the higher it is, the more affinitary we could consider the sale is to a customer or vice versa. And mainly, in this case, we'd recommend the one that is closest in terms of affinity to the customer. So let's see, how are we doing this? In order to choose like the signals that we will want, deep ranker is the solution that we're implementing. We mainly base it on historical purchases. Why? Because we want to maximize either the chances of a customer becoming a buyer, so from visitor to buyer, so purchasing anything, or maximizing the turnover generated. So we take a look at what the customers have purchased in the past. And what we say, okay, if user A has bought in Tommy Hilfiger, we'd consider this as a positive information for the algorithm. And any sale that was available at the same time that this customer has purchased Tommy Hilfiger, we can consider it a negative signal, meaning that the customer could potentially have purchased the second one, but preferred to purchase Tommy Hilfiger. So this is the duality that we would take into account for a deep ranker in order to be able to distinguish between what the customer really likes, what is the affinity that we aim to compute. In terms of information that we feed to the algorithm, to deep ranker, we have mainly these pillars here. So we take into account how is the customer, in terms of characteristics of the customer, like the times in registration and so on. We can also take a look at the age, for instance. Most importantly is the customer behavior, and here it's more on navigation data. So if I have purchased, I have added to the cart, I have visited a specific sale. We have some attributes from this sale as well, so we can know this sale is from a specific brand, it has a specific sector, and so on and so forth. So we can actually build or extract a lot of information of afterwards similar sales that could actually be interesting as well for the customer. We have as well the same characteristics, so again, brand and so on and so forth. We can also take a look at the past of similar sales, how they behave in terms of were they popular We have a specific brand and it's coming again to VP. Was this sale really performing well? Was it not performing well? So on and so forth. And we do also take into account how popular a sale is while the sale is open. Meaning that based on the number of orders that the sale is generating in live, in the last 1 hour or the last 24 hours, maybe it's more interesting or not. And also we can do this as well based on sale popularity based on customer characteristics, meaning that maybe specific sale is more interesting for a certain age group of people. More interesting meaning in this case more popular for a specific age group of people than another one. And finally some context, context meaning because we have different this implementation in different countries, each country is individually affected by the recommendations. Yeah. In total, that depends from the version of the variation that we are actually A/B testing or that we have at that moment, but it goes from 130 to 150 different features. On the training phase, we do consider this positive item, so the sale that was already purchased before, the sale that was not purchased at the same time, and mainly we have all the information about the user, which is going to be the same, and the context of the sale, since we are using this positive and negative that were at the same time, it's exactly the same. So this is actually a deep ranker. It's a CMS neural network, and the idea of the positive and negative is because we are using in this case the pairwise loss. So mainly we have these shared layers in which we're going to input on the first one the positive item, the feature for the positive item, sorry, and for the negative one, the same for the negative. And the idea is that we want to, this would compute a positive score, a negative score, and with this we can compute the loss. So mainly the idea here is that we want to maximize the difference between the positive and the negative. So of course positive needs to be, the S plus needs to be greater than the S minus, because this is how we want the affinity to behave. And the more separated they are, the more the deep ranker in this case would learn that the customer would prefer more this sale than the other one. The loss is actually something that we can play with, meaning that for conversion rate it's quite easy. In this case, it's just the difference of the score, but we can tweak a little bit the way the loss is created in order to optimize turnover. Like for instance, if in that specific computation of S plus minus S minus, we take into account the how much the customer spent on that specific order that he or she made, we can make the algorithm learn more, focus more on not making mistakes on sales that actually generated a lot of revenue for VP, while if there were sales that the economic value of it were not that impactful, in this case we can not take that much into account. This is for the data science part in terms of personalization. Whenever we are actually having this industrialized, whenever we are connecting to VP, there's a full process happening in there. So we have, again, the problem that we had before. So given the customer, given the offer, we use the ranker. Yes, okay. So mainly the way it will work, we'll go a little bit more fast here. For the customer, where he or she connects, we have all the information of the sales, all the information of the customer, all the information of the time in which it's connecting, the site in which it's connecting, and so on. And we go basically one by one. So we gather all the different features, we'll input to the ranker in the model that's already been trained, and this will generate an affinity score. And mainly we'll do this for all the different sales that it's available. And finally, what we will achieve is this recommended ranking based on the descendant order of this affinity score. So this would be what we are actually recommending in terms of the desired ranking for this customer based on all the information that we are using. Of course, this ranking can be unique for the different users. So in this case, maybe let's focus on this is Excel. For customer number A, it's on top, so probably she would like it a lot. For customer B, it's okay in the middle, while on the customer number C, it's more below, so maybe the interest here is really different. And that is the way that we can increase visibility of the different sales of VP, and at the same time enhance chances of purchasing, and at the end, everyone is happy. Just one comment here, this personalized ranking will remain the same for 30 minutes to avoid confusion. So if a customer is connecting to VP, enters into a sale, and then goes back, the ranking will still be the same, just because so it's easier business-wise to maintain the navigation and not make it confusing. We have, this is one of the challenges, business rules prevail. So it's either the sections or in this case an exemplification of a fixed banner. If marketing for whatever reason chooses to fix a specific banner in a specific position, this will always prevail. Of course, if there's actually rules, like if there's sections and so on, and there's other business rules applied on top, this always prevails. So this is the same example as before, but in this case, let's imagine that marketing team decided to fix this one on first position. So it means that the rest of the recommendation will be applied based on the affinity score as well, but taking into account the fixed position. Yeah. In terms of challenges, so George explained before a little bit that the VP core business is actually flashy, so offer is changing every day. And in this case, this is fully personalized, considering, of course, that marketing can still fix banners and so on. But overall, it's fully personalized. And this was the first focus of the project first. Meaning that some of the features used, some of the pipelines built, were mainly created according to the flashy business model. And that means as well according to the flashy data model. So far it was great, everything was fine, and then we had a brand space agreed. Brand space is a marketplace. So in this case it's different. Flashy can last, I don't know, 7 days. You have the offer, it's always the same. If it's there's a product and everyone buys the product, then you cannot sell it anymore, it's sold out, that's it. Brand space is different, marketplace, when a sale can be open for a long period of time, the content of the sale, what is inside the sale, and like the products, or even the prices of the products can change at any time. They can appear and disappear from the homepage based of the business needs, mainly. So we were working on, that was actually a huge challenge, and it is still a huge challenge, how to integrate this marketplace data model to a Flash one. So actually this is working right now in the majority of the countries that has this brand space business. We are still trying to extend it, trying to improve this part in terms of mainly for the features used and the way how we can take into account the information of this of the customer behavior on this scope. And then we have travel. So if brand space was already challenging, travel is even more. In this case, you don't go into either sale and purchase shoes. Here you are purchasing, I don't know, travel to the Caribbean. So of course, business model is much more unique. But we have another challenge here, which is the fact that this part of the information, like the purchase itself, it happens at the provider side. So we are not actually, we as VP, we are not actually selling this. We are just redirecting customers to specific providers. So then it means that in terms of, for instance, some of the features of the sale popularity and so on, this is quite challenging to do, or quite challenging, no, it's not possible. So of course, this can affect as well the way that we want to integrate it into the homepage personalization or the other use cases that we saw before. There's finally some other banners, in this case, which they are really very specific, or very low number of banners, which in this case, we basically do not personalize them. mainly VP scores being, so Flash is the majority of it. We have branch place, we have travel, and with that we can account for the majority of the sales happening at VP. In terms of technical overview, here are the three main sources of information, or data sources. So VP has a data warehouse in Google Cloud. And in this case, we have historic information coming from the internal VP products, so information about the members, the customers, the sales, the orders, products, and so on and so forth. Everything is stored in BigQuery tables. And it depends, of course, from the different information that we have, but mainly it's updated once per day. There's a batch process running every night, meaning that if I plug into VP Data Warehouse today, I will have information from yesterday, but not from what is happening like 1 hour before. We also have tracking from Mixpanel. In this case, we can track, or we can have information based on what the customers did in terms of clicked on a specific banner, clicked on a specific product, added this product to their cart, and so on and so forth. Here, there's two ways that we're considering this information. There's for historic and batch computation, and this data is already stored as well in the VP Data Warehouse in a separated space, but mainly we have the information there. And this is with it's a bit higher than terms of fairness than once per day, but it's still not real time. Of course, we have live popularity for the sales, which in this case we do need the real time processing. So we are plugging, we are directly getting this information through a PubSub, and we process it with the data flow, and finally we start PostgreSQL to do the final mixes with the information that we have from the members in order to do the demographic popularity, meaning that we can do popularity globally speaking per sale, but also we can do it per the age groups and so on and so forth. Last but not least, we have the content of the homepage, meaning that the sales, of course, there's, as I said before, that the sales can open at 7 a.m. So if we go at 6:59 in the morning to 7, the content would have changed. But also, this is not the only moment, and sales also can open at 7 p.m., at 12, even for some specific banners, like the branch place one, the marketplace, and so on. This can appear and disappear whenever marketing wants. Not exactly true, but approx. So we need to know what is the content of the homepage every time in order to provide an accurate recommendation. In this case, this data is exposed to Kafka coming from the navigation team, and we process it with data flow, and we store it again in the Postgres for afterwards gathering this part of the journey with the previous information. Let's go with let's start first with the training pipeline, because it's the easy one. So here we just need historical information. So it's easier than the serving one. So we mainly have these two sources of information, so the data warehouse and the Mixpanel tracking. That's also available here with on the data warehouse with historical information. And first layer that we have is a processing layer, in which, based on all the information that we can receive here, we just gather the information that we need, we just transform it in a way that it's going to be useful for us afterwards, and we consolidate it in BigQuery tables using mainly DBT as the processing tool. Secondly, we have the Bart, the model that creates the features, that afterwards, here it's for the training pipelines, we'll create the features for the training pipeline, we'll create the training datasets, eval datasets, test datasets, and so on. But also, at certain site, we'll see that this layer also exists, and we'll recreate the features, but in a small, slightly different way. And in this case, this model is mainly built in Python, but at the end, what it does is create some BigQuery queries. Depending on the way that we want the features to behave, or depending on the way if it's training, evaluation, test, for serving, this we can play with it, and the way that we can play with it is also using the Jinja part of the project. Then of course we have the model itself, so it's implemented in TensorFlow, Python. Recently we migrated it from TensorFlow 1 to TensorFlow 2, and it was a bit, well, for the training pipeline it was easy, for the serving one it was not that easy. And what was one of the struggles of the team lately. And finally, of course, it would have some, whenever the model is trained, to have some evaluation, in this case offline, nothing happening online. Here we use BigQuery for prediction. And mainly for visualization, we always use Data Studio, even though in data, the data team, there's also the possibility of using MicroStrategy for this purpose. Serving side, we would see a kind of similar behavior for the batch pipeline. Batch pipeline meaning getting information of what has, of what happened up to yesterday. So that's why we're planning to the data warehouse and the mixed panel tracking. We have the same layer of processing in this case. The features happening in feature engineering would change in this case because not all of the features would be exactly computed the same way. Meaning that, for instance, we can use a training site the number of minutes in the sale started, but in this case, we cannot because the number of minutes in the sale started for a customer that connects will depend on the moment that the customer will connect. So that's why it's slightly different, and in this case, we need to well, it's one example of why it can be slightly different, and that's why we need to do some modifications here. Mainly it can happen that either we go for member aggregated features, like this customer has visited this amount of times the brand that it's Adidas. So in this case, it would go into a big table, and otherwise information from the sales that can, like sales-rated features, sales-rated attributes, can change during the day because the sale itself, the sale data in the homepage can change. This, in this case, it's going to the PostgreSQL. And this happens through data ingestion, it's a data ingestion process managed by TechTalk. On the streaming pipeline, we do have as well mixed panel. In this case, it's the same, but it's happening from the streaming pipeline, so the one that comes from the PubSub. And here, mainly what we get is the orders in streaming. So maybe if a customer has purchased 1 second ago, we would have already this information. And also the homepage content that goes to the Kafka, so we have the streaming of the sales. Everything here is handled with the data flow, and then we have this live sales and live popularity that would be stored in the PostgreSQL. So if we reproduce what happens whenever we have a customer that connects to VP, if this customer connects to VP, this generates a request coming from navigation or member lifecycle, depending on the product of personalization. But let's say that this is a customer connecting to VP into the homepage. So what would happen is that we would receive a request coming from a gRPC request coming from the navigation team in this case for this specific member, and we would go and say, okay, let's get the information that we have for this specific member. So we just go into the member aggregated features on Bigtable and gather it. And since this request happened at a very specific time and in a specific country, we would get what is the content of the homepage at that specific time. We would get what are the most popular sales at that specific time. And finally, we will finalize the computation of the features to actually input it into the TensorFlow serving model for the recommendation. And we would serve a list of already ranked codes of the sales, IDs of the sales. So afterwards, in this case, navigation, so this is the homepage, would be ranked with this recommendation. And this is the part that happens usually in 35 milliseconds of that. And I think that's it.
If it looks like I'm excited, because I am. Thank you, Sam, for the invitation. Just wanted to say what I mentioned earlier, like the whole topic is about recommendation systems. Well, yeah, sure, in some essence I think we also recommend stuff, but there's so much to say about recommendations at Spotify. I'm also just one guy. Yeah, if you want to hear more interesting people, you might find them online, I think. Anyway, today I'm going to talk about messaging optimization at Spotify, because that's the team I work in. You may recognize messages like this, like because you listened to previous ML talks, you may like this one as well. So that's what I thought. Who am I? My name is Bart, and as Sam already mentioned, I used to work at VP for quite some time. If you want to work with really very lovely people, go to VP, and if you want to work with even more lovely people, come to Spotify. I am a molecular biologist. It's actually called biotechnology here. You guys are from here, you know what it is. Turned into bioinformatics. Turns out that I really love telling computers what to do, and that they obey. It's awesome, especially when they do stuff that I can't do. Moved eventually to what you could call software engineering. I write code. And then at some point in time, this thing, data science, came along, and I thought, yeah, that's kind of, I also don't belong anywhere. I think I fit in that bucket. So yeah, I did some ML engineering, data science, data engineering, sometimes data visualization as well. That's what I look like, in case you wonder. All right, let's kick it off. Enough about me. So, messaging about Spotify. Messaging at Spotify. So basically, sorry, I didn't have a slide to introduce Spotify. It's a service to listen to music or podcasts. Quite popular. Sorry. But we also send messages. We send different messages, so there's some push notifications. Who has turned off all the push notifications you get from Spotify? Stop doing that, please. Jesus. Turn back on. We also send emails, and there's also in-app notifications, which are quite different. So there are different channels, and there are really different things to think about when you're sending messages. So first of all, why do we send messages in the first place, right? There's different goals for us, and I have to make sure I don't fall off the stage here. And we usually talk about one of these three goals that we're aiming for. So one is consumption. So we really try to convince people to consume a certain song, a certain album, whatever. Conversion, we try to get people to take a subscription, because in the end, that's also how we pay artists. And retention, keep people engaged, keep them happy about the platform. There's definitely some things you want to avoid. You don't want to annoy users by sending too much messages. You could get the opposite outcome. Users could opt out from notifications. Quite some do. Or your operational costs could go through the roof. It's obviously also something you don't want. So, the challenge we're having is we really have to choose wisely who are we going to send the message to, which channel are we going to use, at what time are we going to send the message, and what exactly are we going to send them. And then this fifth thing that I put in the slides seems maybe not entirely related, but I think it's quite important. You want to think in advance, which metrics do you actually want to measure when you're sending messages, what are you actually aiming for. All right, so what do? We're going to break down the problem. Oh yeah, this is one. We're going to break down the problem into some smaller questions to ask, because this sounds like a super daunting challenge. It is. So, who are we going to send the message to? What are we going to send? When do we send it? How? The channel. You could also answer some of these questions with some common sense business rules, right? And that's also what we do. So, who are we going to send them to? When do we send it? How do we send which channel do we use? We have some common rules in place on how we're going to tackle that. And we are actually focusing on what are we going to send them. So basically, you could think of, there are many things you could optimize here. And it's making, obviously, your problem super complex. So I think my first main takeaway message is, maybe you want to think about reducing your optimization space first and optimize that, and at least it can get you going, it can get you iterating on stuff. And yeah, break it down. All right, let's take a quick look at the architecture we're having. So we've broken this down into some different components that answer those smaller questions in isolation. So first of all, there's the message management system. This is basically where we have a bunch of people that are responsible for creating these messages. And what actually do they put in there? Well, they set an audience. This is a message that can go to these and these and these users. They set a channel. You cannot just send any message to different channels. This would really look silly in an email. So you set your channel there. And we set some caps also on the message. So this is a message that you can get only once every 2 weeks, or this is actually a message that you can only get once in a lifetime. Those things are also defined on the message level. And then obviously the content. What does your message look like? Then we have a targeting system. So that's actually where we are going to define which users can get a message right now. That also depends. We also have some capping rules there because we don't want to bombard users with messages. So yeah, there's also some capping rules defined on the user level. And then those two come together in what we call like a resolver service. So this is basically where you're going to match the users that can receive a message with, are they actually part of one of those audiences that we currently have configured in our message management system. And the resolver is going to create a pool of messages per user. So these are the messages that we can send to this user right now. And then there's this optimizer service that comes into play, because this gets the pool of messages and basically it's going to rank them. And now we have this common theme, it's a learn to rank problem. What you get back from the optimizer is a ranked pool of messages, and the best message will be sent, and so you're going to hand off a message user pair to your delivery layer. So we're mostly focusing on the optimizer service here, but I do think it's an interesting way to think about it, break down your problem, and maybe we'll think about optimizing some of these later on. I have to put this one. Right, so message ranking, I already gave it away. It's a learn to rank problem, and what's pretty common about it is, well, it's going to be a model and we're going to have training data and we're going to try to predict which is going to be the best message to send, right? So I guess this will not be a surprise. We have some user features, we have some features related to the message, and we have some contextual features. And then finally we have a reward. I'm deliberately vague about this reward thing, because it depends, you know? It depends on the business goal you're aiming for. It can change over time, it will change during different experiments. It's kind of obvious if you're aiming for consumption, you want certain users to consume a certain thing, that you'll try to collect a reward. Did they actually consume it or not? If you're aiming for converting people, your reward will be, do they convert or not? So your reward can be very, very different. Right, then there's a model. If you remember from the first slide, I'm a molecular biologist. I'm going to try to explain anyway what a DCN network is. So we are using a DCN network. It's a deep cross network. Basically the aim is, I've been reading about it recently because I wanted to explain it to you guys. So obviously you're using a lot of categorical features. Maybe you're all working with similar problems. And what happens then is that it becomes quickly very complex for a model to identify the interesting crosses between your features. Of course, deep neural networks can do that. Can they do that in a feasible amount of time? And what's going to be the cost of serving such a model? So the DCN network was published. If you want to have some more information, there's some links to references here. It's also written in the TensorFlow documentation. Basically, the goal is you're going to explicitly create these feature crossings in your network. That's what you see here in the middle. I've got another picture on the next slide. And you combine that with a regular deep network, which you can put either in series or you put it in parallel. And then it will look like this. right? So this is what we use. You have your cross network here. This is basically where your first layer goes back into your intermediate layers, and then all the way to the top. And then you combine your regular deep network with the output of your cross network. So why do we use it? Because literature has told us that this is good. This is a more efficient way of identifying feature crosses. And indeed, for us, we had some good results with this network. And then we're going to put it online. So what have we done for this particular problem? We are using a contextual bandit, and in our case, it's an epsilon greedy setup, which basically means you're going to try to balance what do you already know with your model, and how can you keep learning new stuff, right? So what you already know, that's your exploit side. So in that part, you're going to call your deployed models, so you're going to try to predict the best possible solution. In the explore side, you're going to try to learn new stuff, and which basically means in our case, you're going to randomly rank your messages. And obviously you do that because then you can collect unbiased training data. We'll get back to that later. So this happens in our optimizer service, if you remember my architecture diagram. And basically a request comes in, you flip a coin with a certain probability of epsilon, and you either go to the explore part or you go to the exploit part. Right. So we don't do that just for fun. The idea is that we're going to retrain our model. And basically what this slide shows you is over the course of a couple of days, you have your prediction service at the top. Every day it's going to collect unbiased training data, so we'll have different predictions of training data. And every day we're going to collect rewards. And as I told you before, definition of rewards can vary, but what's very common is that there will be some delay. So we will, for instance, day X, we're going to collect the rewards from day X minus 3. And so we add this to this training data, and then every day we can run a retraining job, which is also scheduled, and you collect a number of partitions, training data, and your rewards. Right. Okay. After that, I just briefly also wanted to talk with you about some tools we're using at Spotify that make your life as an MLE a bit easier. If it sounds like I'm selling those, it's because partially I am, because I'm really excited about them. If you want to work with them, you have to come to Spotify. That's basically the main message. Right, so at Spotify there's this idea of the development life cycle for ML products, right? So you first have to do some data analysis, exploration, pre-processing, feature engineering, what have you, up until your model serving and observing your model performances online. And Spotify has invested quite some time or effort into building different products that are now grouping in a single platform to support all these steps. And it's called their Hendrix ML platform. It's basically an umbrella of some different products, and I will highlight some of those. So, what's included in Hendrix? There is a product aimed at features. So this is all about helping you store your features for online or offline access. There's a feature gallery in there. There's workflows, which is mainly focused on helping you train your models. I'll get into details of those, don't worry. And then there is a serving product, which will help you to get your model online. Served observability. Core is all about model metadata and stuff like that. All right, I'm not going to explain all of those. Honestly, I don't know all of those, but we do use some of those on a daily basis. And the first one is the Hendrix core, or the ML home, which is basically like, you have some metadata for your models. There's a model registry. If you have a certain problem, you can go there, you can start searching for it, find the right team. didn't mention it, we are fairly a large organization, so it's very common that you don't know who built a certain model, so you do need some internal visibility. Here, there's some leaderboards to keep track of your experiments and your performances. Good stuff. Right, Hendrix workflows is all about training pipelines, so we focused a lot on Kubeflow. You may recognize this screenshot because it's not mine. And also get back to Kubeflow. I think in general, Kubeflow, it offers you this user interface, but it's all about reusability of components, which is pretty cool, of course. The thing that Hendrix also offers is there's also this interaction with your infrastructure. So there is a Kubernetes service available. If you run these pipelines, the service will find your Docker images and will start running it. You don't have to worry about those things. Right, the features part. We used to call this jukebox. So as I mentioned before, it's a set of tools basically to assist you with your online and offline access for your features. There's a feature gallery, so you register your feature, people can find your feature and can reach out to you if they want to reuse your feature. What's also interesting about online access, so there is a library that will assist you to retrieve your online features. It's kind of a way of abstracting away where your features are. It's just you import a library and say, I want that feature, and you'll get it. There's infrastructure also that will deal with, of course, the high load that we expect on those systems. Yeah, and as I mentioned before, it's all about discoverability and reuse. All right, on the serving side, this is what we used to call Salem. So this is basically a service that will deploy your model, and again, we used to be highly focused on the TensorFlow ecosystem, so this is all around TensorFlow serving. But basically, what you do here is you register your model, you say it's this kind of problem, it's a ranking problem, or it's a classification problem, and then Salem knows how it should deploy such a model, put it in a container, spin it up in your cluster, and you have a unified API to query your model. And there's a couple of very interesting things about Salem. Yeah, as I mentioned, so there's also infrastructure. It's going to put it on the cluster for you. But what I find in particular interesting, and I'll highlight that later as well, is there's some prediction and outcome logging out of the box. So if you want to retrain on actual feature values at inference time, then you need to log those, of course, and that's also what Salem does. Right, so how do those three things work together? Quick overview. So on the left side you have this training pipeline, it's Kubeflow. But the other products in Hendrix, they come as Kubeflow components. So you insert your Kubeflow component to say, get me all the training data, these are the features that I want. And then finally, if everything looks good, you run your component, deploy to Salem, and off you go. Online, it looks a bit different. So we have this optimizer service again. So basically what happens is there's this library in the optimizer service that's going to request your features. So it's going to go to Jukebox, get your features back. And then it's going to make a call to the Salem model and get your ranking back. And I also showed here that there's some monitoring out of the box. So when your Salem deployment runs, you get your Grafana dashboards as well to keep an eye on your model's health. And there's this logging, to log your predictions. If you remember from my retraining slide, so that's basically how you collect that unbiased training data. Right, two more things I wanted to mention. I'm going to go very quick because I'm getting hungry. But this is the Experimentation Platform. Quite an interesting tool. So if you run some A/B tests, and at Spotify there is a culture that you should all, well not all, but I mean there's really a culture to run A/B tests or to experiment. And so there's kind of this self-service platform if you want to run experiments, this is how you do it. There's an experiment planner, which is pretty obvious, it's to plan your experiment. I love the name. But basically the idea is you define your experiment here, some metadata, you attach whatever it can be, a Google Doc saying, okay, this is why I want to run this experiment. These are the metrics that I'm actually aiming for at improving. There's an interaction on the right side with this metrics catalog. So this is where The most common metrics that you might want to track during your experiment, they are predefined, and you just reuse those, and they're computed by when your experiment is running. And that's a pretty cool thing, because basically when your experiment is running, you can also configure what's called guardrail metrics. So, of course, you have some target metrics, things you want to improve, but you can also, you might not want to harm certain things, so you can configure some guardrail metrics. And the experimentation platform, while your experiment is ongoing, will keep an eye on your guardrail metrics, and if they really go down, you get an alert. Say, okay, you might be harming the business, so you might want to take your experiment offline. Then there's the remote configuration. Basically, this is all about setting properties which is necessary for running your A/B test. So when you've configured your experiment in your experiment planner, you can basically assign a property, and a user that will reach your service, when a user reaches your service will reach out to the remote configuration saying, what do you know about this user? And the remote configuration says, oh, there's an experiment ongoing and this user should go into control. And so the remote configuration is also responsible for persisting that information if necessary, but usually in our case, a user should stick to a certain bucket. So that's all handled by the experimentation platform. While I'm here on this slide, just also want to tell you guys there's a difference in Spotify between machine learning engineers and data scientists. So data science is really considered more on the analytical part, whereas machine learning engineers is really more building stuff, building data pipelines, building neural models and stuff like that. This is where we meet. So this is where I say, okay, we have this new model. I reach out to Olivia, who's the data scientist, and say, okay, which metrics shall we aim for? I didn't tell you that there's some statistical computations in this experiment planner happening. It's going to estimate your sample size if you want to have a certain power, if you want to be able to detect differences between a certain metric or on a certain metric with a certain confidence that you need to reach a certain sample size. So it's going to assist you with that. Fun. Final thing I want to mention, maybe not that relevant, but this is what I use on a daily basis, which is Backstage. And Backstage is called a developer platform, a developer portal. And it's basically an integration of a lot of things. All the services we have are there, you can find them. Data sets we have are listed there, you can find them. Workflows that are running, that are scheduled. It's all integrated in Backstage. Docs from libraries, from services are all there. I think I have a slide where I listed a few of the interesting features there. Yeah, so as I mentioned already, what we use it for, like finding data sets. Do we have a data set around somewhere in the company? You can spin up some infrastructure from Backstage. There's some integrations in there. It's monitoring of your scheduled workflows, a search, whatever. And it's open source. Yeah, cool. You can look at it. All right. Basically, people. With that, I want to conclude because I see that the pizzas are there already since the start of my talk. However, still, thanks all for being here. And if you have questions, please ask now or later, whatever. Thank you.